Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi, and welcome to another episode of Lost in Math. I'm your host, Mr. Wheeler, and today we're talking about theoretical probability. When outcomes in the sample space of an experiment all have the same chance of occurring, we say that those are all equally likely. In order to talk about theoretical probability, we have to assume that all outcomes are equally likely. So if I want to find the theoretical probability of an event, it's how many times that event can occur over the total number of equally likely outcomes. If we have an experiment where all outcomes are equally likely, that experiment is said to be fair. We're going to assume that all experiments involving coin flippings and dice rollings are fair. That's not always the case, but we got to start somewhere. If we go in our notes and look at our examples, in this example we are rolling a standard six-sided die. And example A asks us the probability of rolling a 3. Now to find the theoretical probability of something, it's the number of ways something can happen over the total number of equally likely outcomes. So how many ways are there to roll a 3? 1. I roll a dice and it lands on a 3. And how many equally likely outcomes are there? 6. There's 6 total numbers in our sample space. I could roll a 1, 2, 3, 4, 5, or 6. So the theoretical probability would be 1 over 6, or 16.7% if I rounded it to a percentage. Example B asks for the probability of rolling a number greater than a 3. So theoretical probability, again, number of ways something can happen over the total number of equally likely outcomes. So how many ways can I roll a number greater than a 3? There's 3 ways. I could roll a 4 or a 5 or a 6. So that's 3 possible ways. Out of the 6 total ways, there's still 6 numbers I could get on my dice. So theoretical probability would be 3 over 6, or 1/2, which is 50%. So there's a 50% chance of rolling a number greater than a 3 on a roll. Next up, we're going to talk about complements. The complement of event is everything that is not included in the event. An event plus its complement will always equal 1 or 100%, depending on whether you're talking about percents or decimals or fractions. The reason being, an event can either happen or it cannot happen, and that's all possible outcomes. So if I take the probability of something happening plus the probability of something not happening, I'll get 100% or 1, because an event and its complement encompass everything there is. So on the example, it says a weather forecaster predicts a 20% chance of rain, and it asks what's the probability that it's not going to rain. That's a complement. The probability of the event raining was 20%, so we want the probability of everything else, which is the probability of it not raining. Together, they should make 100%, so the probability of not raining would be 80%, 100 minus 20. So the complement in this would be the probability of not rain, and that would be 80%. On the back of our notes, we're going to talk about odds. Odds are another way to describe the likelihood of an event. We got 2 kinds of odds in favor and odds against. Odds in favor of an event describe the likelihood an event will occur, and odds against an event describe the likelihood an event will not occur or will fail to occur. Odds are usually written like this. A colon B, we say A to B though. They can also be written A to B or A over B. All those are perfectly acceptable. If we're talking about odds in favor of an event, It's the number of ways something can happen over the number of ways something can fail to happen. Talking about odds against an event, on the top this time it would be the number of ways it can fail to happen over the number of ways it can happen. So it would be can't to can for odds against an event. Odds, whether they're odds for or odds against, are made up of ways an event can happen and ways an event can fail to happen. So they're made up of the two complements. So if I add up my two numbers in my odds, I should get the total number of possible outcomes. That's the bottom number in our probability. Probability, remember, was ways something can happen over total number of possible outcomes. So keeping this in mind, we can convert between odds and probabilities, depending which one we want to use. So if we look at our examples on our notes, we're going to try converting between probability and odds. Example A says that the probability of drawing a heart out of a standard deck of cards is 25%, and it asks us to find the odds of drawing a heart. Odds of drawing a heart, so that's odds in favor of drawing a heart. First we have our probability, 25%. In order to convert between odds and probability, it's best if they're fractions, so we can convert 25% into a fraction. Percents compare numbers to 100, so that's 25 over 100. You reduce, so 25% is the same as 1/4. So probability is the number of ways an event can occur over the total number of equally likely outcomes. So we look at our 1/4. That 1, that stands for the number of ways the event can occur. So that's the number of ways there are to choose a heart. And the 4 represents the total number of equally likely outcomes. So odds, it asks for the odds of drawing a heart. So that's the odds in favor of drawing a heart. So odds will have the number of ways I can draw a heart to the number of ways I can fail to draw a heart. Now the number of ways I can draw a heart, that's the same as in probability. There was one way to draw a heart. So the numerator in my odds is going to be 1 because there's still one way to draw a heart. On the bottom, I'm looking for the number of ways to not draw a heart. Probability, the 4 was the total number of outcomes. One of them was drawing a heart, so if I take that out, then I'll have 3 outcomes that are not drawing a heart. So on my odds, there are 3 ways to not draw a heart. So now on my odds, I have 1 to 3, 1 way to draw a heart, 3 ways to not draw a heart. To check, if I added those together, I ought to get the total number of possible outcomes. 1 plus 3 is 4. 4 was the total number of outcomes in the denominator of my probability. So the odds in favor of drawing a heart are 1 to 3. Example B, it says the odds against choosing a green marble from a bag are 5 to 3, and it asks us to find the probability of choosing a green marble. So first I'll write out my odds, 5 over 3, and then I got to think about what each of those numbers represents. These are the odds against choosing a green marble. Odds against, number of ways something can fail to happen over ways it can happen. So on the top, my 5 represents the number of ways I will fail to draw a green marble, and the 3 represents the number of ways I can draw a green marble. It asks for the probability to choose a green marble. So I look at my odds. The 3 represented the number of ways I can choose a green marble, so that'll be the numerator in my probability. On the bottom, probability is the number of ways can happen over the total number of equally likely outcomes. So there's 3 ways to draw a green marble, and on the bottom there were 8 total options. I had 5 ways to not draw a green marble, 3 ways to draw a green marble, so together, since they're complements of each other, that'll be all possible outcomes. 5 plus 3 is 8, so that's where the denominator of my probability comes from. So probability of drawing a green marble was 3 over 8. So if I wanted to convert that to a percent, that's 37.5%. So I had a 37.5% chance of choosing a green marble. All right, well that finishes up our notes on theoretical probability. I hope you enjoyed the video. And as always, get me out of here. Bye guys. Oh. talking about odds. We got two different kinds of odds: odds in favor and odds against. Odds. Oh, sorry. On the back of our paper, we're going to talk about odds. Odds are another way to something can either happen or that's not. I'm going to stop. This has all been bad. Theoretical probability. In order to talk about that, we have to assume that all out. So on the example, it asks. So on the example, it says. Back of the page. And odds against an event describe the likelihood, and they write it as A to B. Then we write it as odds in favor of an event. Odds in favor of an event are a number of ways it can. To express odds in favor of an event, brown cow, brown cow. Odds are often used in, I guess I can't talk about gambling. Example A says that the probability of drawing a hair. So probability, it's the number of ways something can happen over the total number of ways